Hello, and thank you for joining us at this Google Maps platform breakout session. My name is Clementine, and today I'm going to talk about why location data is going to change the way that we play games. When I was a kid, games and maps were two very separate things. Games meant Super Mario, and maps were these big folded paper things that lived in the glove box of our car. And they occupied two very different worlds. One happened at home, one happened on the road, one was about fun, and the other one was about utility. But if you fast forward 15 years to today, maps and games are now much more tightly linked. Location data and the way that humans engage with it has undergone a paradigm shift in the last decade. We used to use paper maps. These were static physical tools that helped us navigate mostly unknown paths. Later, maps went digital, but they were still very static. And interactivity was super limited. So the map was on a screen, but you had to click a little arrow to pan to the area that you cared about, and then click a little magnifying glass to zoom in. And if you wanted directions, you had to print them out, and the route didn't update if an accident occurred along it. Then smartphones came along and ushered in another paradigm shift. So suddenly maps were location-based. They actually reflected the area around you, and they even reflected the direction that you were facing. So we came to rely on them for more things more often because they captured the world immediately around us. And then with the advent of big data and machine learning, maps became truly dynamic and even real-time. So we started to rely on them for navigating even known routes because they could tell us about road closures and traffic and slowdowns. We could now use maps to hail rides or to choose a restaurant based on its actual current wait time. So along the way, maps transformed from something that we use maybe a few times a year or a few times a month to something that's basically a near constant companion. And along the way, engagement skyrocketed because we were able to reflect more and more relevant real-time context about users. And this transition from static to dynamic to real-time matters for more than just maps, because it turns out that life is a location-based experience. So socializing, for example, doesn't necessarily feel location-based, but of course it is, because you want to meet up with people in person or swipe right on someone in the same city or share moments with people who have been to the same place as you. Eating doesn't necessarily feel location-based, but it absolutely is, because you realize this when you get connected to a pizza place that's actually on your route home. And then the app ensures that the pizza leaves the oven as soon as you arrive to pick it up, or that it arrives at your doorstep as soon as you get out of the car. This stuff is miraculous, and we all want experiences that feel miraculous, that are relevant, ultimately. And location has a relevance that really spans industries, spans demographics and geographies, because at the end of the day, your location is personal. Okay, so now what does any of this have to do with games? So this transition in how location data shapes our experience of the real world matters for the gaming industry and is poised to change it. And this is a really big deal because 1 out of every 3 people in the world plays games. That's 2.3 billion gamers, and a really crazy increase of 13% over just last year. And the growth in mobile gaming in particular has been astounding. It now accounts for half of that market, and itself is projected to be a $138 billion industry in 2018. So just as it did with maps, location is poised to transform gaming. Soon, gameplay will adapt to suit your bus ride to work. And then it'll adapt again during your lunch hour, and then it'll adapt again when you're at the grocery store after work. And critically, it'll account for other people. So when there are lots of other people around, you'll be able to team up to battle or show off to your friends. Now, with maps, this transition was much more predictable in a way because maps already reflected the real world and they just had to get better at doing it. But with games, this is much more about mixing realities. And so this is where AR comes in. Players need to be able to see the game world and the real world at the same time and experience both at the same time. To make AR work well for gaming, you need two things, at least, but mostly two things. The first is you need blended reality to look good and work the way that you expect. And the industry has been working hard on this for several years. It turned out to be harder than we expected. But we've made colossal progress on this, and I'll show you that in a bit. The second thing that you need is multiplayer experiences. And this requires not only sharing game state, but also sharing a model of the world. And the promise of mixed reality and the experiences that are really interesting come when you have both of these things. So how close are we to that promise? I'm going to show you a video. OK, here we have two Googlers going head-to-head in a battle for the ages. These dinosaurs are very special because they're being rendered in a shared AR world, thanks to something called cloud anchors that allows two or more devices to share a reference frame. And this is really important because it means that these two players are seeing the same dinosaurs in the same place at the same time. So now, instead of an isolated experience, they can actually show off to their friends or team up or have a referee keep score. But dinosaurs aren't that interesting at room scale, so I'm going to take this outdoors. That's better. All right, so what's important here is that these players are actually experiencing the same virtual elements in the same real-world space. And we're all seeing it as well, so anyone can join in or This stuff is hugely exciting, and it's particularly exciting when you combine it with the forces that I mentioned before. So first, you have this meta trend of location-driving engagement across industries, turning things from static experiences into much more personal, much more relevant real-time experiences. Second, you have this explosion of growth on mobile. And third, you have maturing capabilities in AR. When you put these things together, you see that the gaming industry is really at a tipping point. And that's why we set out as Google Maps platform to create an offering specifically for game developers, to help developers take the next step in this evolution and build mixed reality experiences that are at global scale. Let me show you. All right, so with this product, we wanted to make it easy for game developers to build global, mixed reality multiplayer games. And we built this product based on developer demand. So later I'll bring one of our developers up on stage to tell you a bit about his experience. But first, in talking to developers, we found that they wanted mostly three things. The first is access to Google Maps. But of course, this is much more than a map at this point. It's an understanding of the world that's evolved over 15 years, and it includes everything from ratings and reviews to the actual shapes of buildings to the opening hours of landmarks. And very critically, this data is fresh. We make 25 million edits a day to reflect the pace at which the world is changing. And it's all backed by the same infrastructure that serves billions of daily requests to Google Maps. Second thing is that game developers want the real world inside of the game engines that they're already using, where they can access a whole suite of tools for game development. So we brought the real world into Unity, which is the by far most popular engine for creating mobile games. Here we do all of the heavy lifting for you. You don't need to have any experience working with geodata. This allows developers to focus on doing what they do best, which is creating great gameplay. The third piece, and in some ways this is the hardest one, is designing gameplay around real-world places. I'm going to talk a bit more about this because, as I said, it's really tricky. So to understand why this is hard, imagine that you're building a scavenger hunt. So it's up to you to decide where players need to go and what they need to do when they get there. That's actually already hard, but now imagine that you need to expand that scavenger hunt to a city on the other side of the world that you've never been to before. That's harder. And now imagine that you need to expand that to every suburb and town in the world. This is really, really difficult. To do this requires a huge, detailed understanding of your player's environment no matter where they are. No matter where they are, you'll want to know what people take pictures of, what they ask for directions to, which areas are kind of vibey and interesting that players will enjoy exploring, which areas are off the beaten path that players should be like extra rewarded for finding. So you want to know all of that, but also just knowing all of it isn't enough because you also have to find some sensible way of prioritizing between all of these signals to find the actual best place for your user at that moment in time and space. And as a bonus round, these things are constantly changing. So Moscone, for example, which is completely packed at lunchtime, it's like pretty quiet around here at night. And busy shopping malls can turn into restricted construction sites, and they do all of the time. So you need some system for keeping this stuff fresh as day transitions to night, as rain transitions to shine, and as no trespassing signs go up also. So hopefully I've illustrated that this is a really hard problem. Now, how do we help you solve it? We've built something called the Playable Locations API specifically for this problem, and its job is to help developers find the best places to play games anytime, anywhere. We start by finding enough of the right kinds of points. First, we just want to make sure that a player never opens your game and finds an empty map, finds nothing to do. But then we go through and we remove all of the places that don't seem very suitable for games. So we don't want points that are in the middle of roads, in the middle of water, or anywhere else that's inappropriate for gaming. And it turns out that the world is full of very unplayable places, and often they're unplayable for non-obvious reasons. So just one of 1,000 examples is that parks and cemeteries look very similar on a map, but they serve two very different cultural purposes, and games need to be able to tell the difference between those. So after removing all of the bad points, we start to think about how a developer might want to rank these points in their game. And just one interesting signal, we use a huge number of signals to do this, but one interesting one is recognizability, because it turns out that players get really frustrated if they can't tell where you're directing them to go. So we spend a lot of time trying to figure out the right mix of recognizable and pedestrian accessible and interesting and unique points in the world. But also, the right mix depends on the game. So we give developers a lot of control in the API through rules and filters to customize the mix for their game. For example, if you're a social game, you probably want points that are in busy, high traffic areas. On the other hand, if you're an exercise game, you might want points that are in parks or along jogging paths or on beaches or boardwalks. Or a lot of games are just designed to be leisurely and to fit seamlessly into people's weekend brunch routes or, favorite cafe locations. We also give you a lot of metadata in the API to do this well. One example is place type, so you might want to ensure that a game has no points of type police station, or you might decide that every place of type park has a castle in the center of it. Or you could interpret place type very literally and put treasure chests at banks and provisions at grocery stores, and power-ups at doctors' offices. And if you did something really simple like this, already you would have a game that works as well in downtown Tokyo as it does in suburban Sydney or rural California. And getting to that end state manually is virtually impossible because it requires knowing so much about the player's environment no matter where they are. So with this API, the idea is that you can design your game once, you can make these decisions once, and then know that they'll work everywhere the Google Maps works, which is in 220 countries in the world. So that means gameplay wherever your players are, and it's billions of things that developers don't have to think about. So this piece of the puzzle is very powerful. Okay, that's a sneak peek at how we help you place gameplay in the real world. Now we're going to look at how we've brought the real world into the Unity game engine. All right, so what you're seeing here is Manhattan inside of Unity, rendered by the Maps Unity SDK. Our SDK makes it really easy to turn this blank canvas into a stylized game environment. So here's an example. Notice how we've applied custom textures to buildings, roads, and parks. So developers have control over this piece, and that allows them to create whatever their designers dream up. You have fairly fine-grained control over this, which means that if you prefer fantasy, for example, this same street corner could be a medieval scene or like a really crazy psychedelic Candyland thing. We'll work more with this psychedelic Candyland theme. Okay, so you have fine-grained control over this process, which means that you could use place type that I mentioned before to, for example, turn all of the shops into chocolate bars or turn all of the restaurants into gingerbread. Changing the heights of buildings is really easy too, and through simple customizations like these, you can see how you can start to create a world that looks really unique, but is still based on the real world. So now that we've established the look and feel of the game, we're going to add some location-based gameplay. So what I'm going to do is place mission points at prominent locations throughout the world so that my players have somewhere recognizable nearby to go. And even though I'm still looking at Manhattan, this is going to work everywhere in the world. My missions will always end in prominent locations just as I have designed them to. So the green dots here are playable locations around my player. I'm going to select the most prominent ones and turn them into giant rainbows, which will denote my missions. Great. I can also use place type to put virtual candy stands at every real world store. Or, there we go. As another example, I might spawn gummy bear characters at all of the real world restaurants. And this is an interesting example of where you might want multiplayer experiences because restaurants tend to have very social atmospheres. Lots of people gather there. Again, these could be dragons and treasure chests or spaceships and floating loot, whatever suits the look and feel of your game. Now, it's important to bear in mind in this case that this is actually all happening inside of the Unity game engine. So that means that if I press stop, you can see that the scene is empty because all of this is generated on the fly based on the player's actual location. So we include lots of other features too in this SDK to help you with styling. 9 slicing helps you style arbitrarily sized buildings. Parapets let you add gargoyles and other great things to the roofs of buildings. Borders for simulating contact occlusion shadows. Road names, building names. We integrate with Unity's lighting system so that you can create a really nice day-night cycle, which you'll see later in one of the games. This is also all designed to be performant on mobile, which is really powerful. And most important of all, Unity is a 3D physics engine, which means that you can use real geometry in a physics-based game. Not dramatic at all. All right, so enough about features. Now we're going to look at some examples of how far you can push the platform. So The technique used to create this scene is a little bit different from the previous scenes. Here, procedural rules were used to generate a city that matched the real world's layout. So down below, you can see cars driving around, lampposts, power lines. And as we zoom in, you can see just how detailed the game world is. There are cafe tables, shop fronts, people. Let's look at another example. So this world looks very different from the last world, but it's actually made using the same technique and even by the same developer. The way that the buildings work is really cool. They assemble themselves from modular components to match the real world's layout. Or to put it another way, the buildings are sort of stylistically grown to match the real world. And again, what's amazing about these is that they were all created by a single developer, Adam Goodrich of Procedural Worlds, in a matter of weeks. And you can see that he was able to achieve a really shocking amount of detail in a very short amount of time. All right, we'll look at one more example before we move on. This is a road running through Glacier National Park, Montana. And here, the trees, the rocks, the clumps of vegetation, they were all procedurally generated down to individual blades of grass. So what you get is this vast open world environment complete with lakes, rivers, mountains, deer, wilderness areas. And what I love about this example is that it really shows that you're not limited to these busy urban centers when you're creating location-based games. All right, so quick summary. We want to make it easy with this product to do three things. First, create dynamic experiences at global scale. So we help you connect to your players' surroundings no matter where they are and no matter how many are playing at once. Second, create completely custom game environments. So you can fill parks with trees, oceans with waves. You can turn rivers into lava flows. Whatever your vibe, we can help you blend it with the real world. And third, we help you choose the optimal real-world places for placing in-game objects. This means that you can create experiences that resonate with your users, whether that means taking them off the beaten path or adapting to fit their regular commute. So, we announced this product at the Game Developers Conference in March, and we're already very busy playing the first 4 games that have launched since then. I'm going to talk a little bit about them. So the first one is Yokai Watch World, and this is only available in Japan. It was built through a collaboration with Gung Ho and Level 5. In this game, players activate a radar to find yokai characters hidden in the real world, which they then capture using AR. But critically, then, once they own the yokai, they can attach them to other players. And then as that player moves throughout the world, the owner collects special rewards based on where they travel. Next up, we have The Walking Dead, Our World. This was built by Next Games and based on AMC's mega hit. So this is an AR survival game, and in this game, characters form alliances, battle walkers, build safe havens, and just generally get by in the post-apocalyptic world. This one is a really interesting example. So developer Mixi recently added a location-based mode to their phenomenally popular game Monster Strike. In this game, which is all about monsters, as the name implies, you visit Monstops to level up your monsters. And it's really exciting to see existing games start to leverage location, because, like I said, Monster Strike was already a hugely popular game, but now they're using location to build experiences that are relevant no matter where their users are, when they're at home, work, or in a local coffee shop. And then finally, we have Jurassic World Alive. And here today to talk to you about that game, we have Sebastian Fournier. So I'm going to hand it over to him.
My name is Sebastian Fournier. I'm the lead programmer at Ludia for Jurassic World Alive. Early last year, we started working on that project, and we wanted location to be a key part of the game. We explored many different solutions before meeting with Clementine, who introduced us to this new technology. Immediately, we were excited to use Google data for our game. And actually, the other solutions we explored were mostly navigation-oriented. Google solution was provided features and support for gaming. That's how our collaboration started. So let's look at the game. So, the radar view. The radar view is used to navigate the world, to find dinosaurs, also supply drop and events. You can see far away, and as you move, you will uncover new dinosaurs around you. Also, the style of the map will change when we transition from day to night. In the drone view, the player is catch a dinosaur to extract DNA in order to incubate new species and to improve them. We also decided to show the real 3D building around the player to create a more immersive experience. Now, we'll talk about some challenge. Sometimes people don't want dinosaurs in the backyard, so we developed a system to define no dino region. And also using Playable Location API, we'll offer the player to report undesirable points. And the battle against the cheater, the eternal battle against the cheater, particularly the location spoofer, where people pretend to be somewhere they are not in order to cheat in the game. On that side, we're excited to partner with Google to tackle that challenge, which has plagued the industry for many years, and make the game less fair and fun for all players. We collaborate closely with Google. We discuss openly about solution, idea, priority, and also issue. And we got support on everything from the setup to backend recommendation. That was great, and that's just the beginning of what we think our game can do with real-world data. Thank you.
All right, thank you, Sebastian. So we are already busy catching dinosaurs and battling walkers and leveling up our monsters. But we're also excited to see what ideas make it to the real world stage next. So as I mentioned earlier in the talk, we really think that maturing AR capabilities combined with this explosive user growth on mobile and the real world data that's now accessible has brought this gaming industry to a tipping point, that we're going to see traditionally passive mediums like movies and TV sort of break out of the living room, and traditional mobile, PC, and console games break out of their designated screens. Google is betting big on this space, so we're here to help. From AR, core, and maps to YouTube and cloud, we're here to help you shape the next generation of games. So if you're building something that has real-world elements, or if you have an idea that you think belongs at global scale or on the real-world stage, please reach out. I and some members of my team, as well as Sebastian, will be at the Media and Entertainment Zone in Moscone West today and tomorrow, and we're happy to answer your questions. You can also go directly to this website and sign up to use the product, and our team will reach out to get you started. Thank you, and enjoy the rest of CloudNext.